Jain everyone. I am Shruti Jain, Assistant Professor of AKGEC Engineering College. I am in MC department, and the topic that we are going to study today, or we are going to learn a little bit in detail about, is structures and unions in C. This topic is covered in the subject Problem Solving Using C, and the subject code is KCA 102. This is for MCA students of first year. So understanding what structures is, first of all, structures is a collection of heterogeneous or the different data types. So till now, whatever data types that are available with us are with the same data type. Like if I want to have a value of in data type, then that in data type value or the array that if I am creating, that array will contain all the values of the in data type. Or if I am declaring a float data type array, in that case, all the values that are of the float data type will be stored. But if we are talking about structures, structures has a collection of different data type elements in just a single structure. So when we are using the structures, we use the struct keyword, and each element in C structure is called the member. So that means that each member in the structure can have a different data type. It is not necessary that it will have all the elements of the same data type. The data types could be different in structures. So if we look at the syntax of structure, we have it as struct with a structure name, and then it will have the members of different data type. The data type could be same or it could be different. If we look into the example, we have a structure of student. That means we are making a structure wherein we are storing the details of student. Now, when we are talking about the details of student, it could be anything. It could be the name of the student, the class, the roll number, the age, the marks, anything. So, because everything will be of different data type, here we have roll number and age that are of int data type. And the name of the student will be a string. That is why we have taken it as a char data type. One important thing that we need to notice over here is this structure is always getting end by a terminator. So we need to complete this structure by a terminator. Now this student has become a structure which will have different members. It will have the three members as roll number, age and name, and it will be accessed using the student data type kind of. So declaring a structure variable, it allocates the memory to the structure variable. How it allocates? Now structure name and the variable name. So struct student S, we have a struct with a structure name, that is student, and now we have named the student as S. Now this S will have in the memory as, the first memory will be allocated to the roll number, the second memory will be allocated to the age, and if we look back over here, we have for name 10 memory allocations. So here we'll have S name 0, like 10 memory allocations, 0th index, first index, second index till the index 9. So this whole is the memory allocated to the simple variable, that is S. Now when we want to access those, how do we access? We use the dot operator over here. So members of the structure variable are accessed using the dot operator. How to use that dot operator? Here we have this structure student S. Now this S will now be accessing the roll number. How? S dot roll number. For the student S, what is the roll number? This is 1. For the student S, the age will be stored over here. And for the student S, the name will be stored over here. For example, we have the roll number as 3. So in S dot roll number, the value will be stored as 3. The age of the student is 18. So in s dot age, the value would be 18 over here. The name is Ram, that will be stored in s dot name as Ram, followed by a null character. So this is how we access it. If suppose I have another one, struct, I have two things, struct student s comma s1. Now here I have two names over here. So here for roll number, we'll have a different roll number for S and we'll have a different roll number for S1. Similarly, for S we'll have a different age and for S1 we will have a different age. So the memory location that we have for S, the same memory allocation we'll have for S1 also. So for different students, we have different memory allocations. Now this was when we were just taking an example. Now if you want to initialize those values, we do it by struct student s equal to, then the first one, because in the structure we have roll number at the first place, age at the second place and name at the third place. The same sequence will be followed when we are initializing the values. So this would be going for the roll number, this 18 would be going for the age and this Ram would be going for the name. So the same thing can be initialized in this manner, where the first variable will be taking the first member, the second value will be taken up by the second member, the third value will be taken up by the third member. Now here we have an example wherein we are reading the information of a student from the keyboard and we are just printing the same using the structures. Now when we are using the structure definition should be given at the top so that later on it can be used in the program. So here we have included the two header files to give the definition to the user defined functions that we have. Now a structure student has been declared over here with the three members, roll number, age and name. In the main function we have one student named S. Now when we are inputting the data from the user, we'll input it again using the dot operator as s.roll, s.age and s.name. So that will input the roll number, age and name for the student S. Now when you are displaying the data, again we have to use the dot operator and display the roll number as s.roll, the age as s.age and name as s.name. So whatever values you are inputting, those values will be inputted with the structure name along with the member of the structure. Both the things need to be there. Both are joined using the dot operator. Now this was just one structure element that we created. Now we can have array of structures, like if suppose we have the student and each student would be having the roll number, age and the name. Now for one class, suppose we have 46 students or maybe 50 students and we need to store the data of those 50 students, then it would be highly impossible for us to have the names in this order. For 50 students, S, S1, S2, S3, S4 and S5 and so on till S50. So for that, we create the array of structures, wherein the array of structures again is a kind of an array. Here we have the student name. So we have S students of size 100. There are suppose 100 students over here. Now how will the values be initialized? For the first one, suppose we are taking for S3. S3 will have a separate space for roll number, age and then the 10 elements, like we had the name of the memory storage for name was 10. So we have the memory storage of 10 over here for name. So this is for one student that the memory allocation is there. The same memory allocation would be for S0. So S0 in this location will have the roll number, will have the age, and also it will have the name in it. So this memory allocation will be for all the students that are there. Now, let's understand it with the help of an example. We have a structure that would be reading the details of 100 students from the keyboard, and it is being printed on the console. Now, the first thing is we'll have a simple array which talks about a single entity student, what all things are required. So, the things required over here are roll number, age and name. So, that is declared in the structure here. Now, we need to have an array. So, here we'll have the struct student, an array of 100 students. That means we are taking the information of 100 students from the user. So, to input the 100 values of the student or the information of the 100 students, the way we were doing in arrays, here again we'll run a loop starting from 0 till 100. So, here we have a for loop wherein for each student, that is SI, for each SI over here, each SI will have a roll number, will have the age and will have the name. So, in the for loop, we'll ask the detail of the student, SI.roll number, SI.age and SI.name. So, in SI.roll number, the user will be inputting the roll number, the age and the name of the student. So, this is how the values are inputted. Same goes with the displaying. So, again, we'll be using a loop and all the SI roll number, SI.age and SI.name will be displayed. So, for the first student, the value of I is 0. So, S0.roll number, how it will run? For the first student, it would be S0.roll, S0.age, S0.name. Now, when the value of I increases, the same thing happens for S1.roll, S1.age, S1.name and so on. So, for like this, it will go till 99 so that the details of all the 100 students are stored. The next topic that we have is nested structures. Now, nested structures are basically used when we have to suppose store the marks of the student as well. So, we have a structure within a structure is basically a nested structure. How? Suppose I have a structure named marks which is storing 3 marks of the students in M1, M2 and M3. Now, each student, coming to the next structure, each student again will have a roll number, age and name that we have seen already. Now, we'll be using this structure marks as a member of the structure student. So, what it will do, it will, once you call this student structure, it will call this mark structure and then these members will be accessed. For example, till this we have already seen how to access a variable like s.roll, s.age, s.name. Now, because we have a structure marks being called with a member m, so here we'll have s.m. Now, this m will call back to this mark structure. And then we need to access these members. So, we'll have to use another dot operator to access M1, M2 and M3. So, S is for the structure student. This struct student will be calling its member M. Now, M because is again a structure, it will again call its member M1 and it will store the values. Now, in the memory, how will the space be allocated? Roll for age, then 10 memory allocations for name, then for M1, M2 and M3 which are accessed by S.M1, M2 and M3. So this was all related to structures. The next topic that we have is union. Union is also a kind of it is similar to structures, the way we are having multiple data types enclosed in a single structure. Here again we have multiple data types enclosed in the union, but there is a small difference between the structure and the union. So coming to structures, structures are user defined and they take more memory, because if we look over here, the memory allocation is for separate member over here. But in union, that is not the case. Unions are mostly used to reduce the memory space that we are allocating in the structures. Sometimes memory need to be used efficiently in applications like writing device drivers. That is why we have a concept of union. Now, union is a special data type available in C that allows storing different data types in the memory location. Now, union can be defined with many members, but only one member can contain a value at a given time. That means here the memory overlapping takes place. Unions provide an efficient way of using the same memory location for multiple purposes, and the unions are created using the union keyword. Let's take an example. Here we have the syntax of union, where we have the union, union name, and rest are the same things, the way we have done in structures. So in structures, here we had struct keyword, and because now we are making union, here we have the union keyword. Now, the main difference comes in the memory that is allocated to the union variable. Now, if we look back into structure, if we recall, for structures, a separate memory allocation was for roll number, for age, and for marks and name. But here, the variable or the member that is taking the maximum memory, that memory is allocated to the union, and that will be shared by all the data members. So if we are talking about roll number is taking this much of memory. The same memory will be consumed by marks and maybe more as per the requirement of the variable. Now if we talk about name, name would again be starting with the same memory address and taking up the memory. So here the memory allocation is reduced. The space that is being allocated to a variable is reduced as compared to the structures. So coming to the difference between structures and union. In structures, the keyword struct is used. So keyword struct is used to define the structure. While if we talk about union, the union keyword is used to define the union. Now in structures, the amount of memory that is required to store a structure variable is the sum of the size of all the members. That means it takes different memory for different members. A separate memory for roll number, a separate memory for age, and the separate memory for name. But in case of unions, the amount of memory required is always equal to that is required by its largest member. So as we have seen over there, we had the roll number, we had the age, and we had the name that was taking the memory of 10 bytes. Now because this is the largest variable or the variable taking the largest memory, all these variables will be sharing that memory space. So there we had the sum of the memory spaces, but here the amount of memory that is required is equal to the memory required by its largest member. Next, in case of structure, each member have their own memory space. As we have seen over here, roll number will have a separate space, age will have a separate space, and name will have a separate space. But in union, one block is used by all the members of the union. The same block of memory will be shared by all the variables, all the members of the union, be it a roll number, be it the age, or be it a name.